Hey guys, it's Jason here. Welcome to another episode of my linked list video series. I'm sorry this one has been quite delayed. I've been kind of struggling with the recent exams coming up, and I haven't had much time to do these videos, but I understand that the prac exam is coming up pretty soon, so I'll try to get a couple more videos after this one. But in this video, I'll be doing reversing a list. So what this function does is basically it takes in a list and then reverses the order of the elements. Okay, so in order to test that, we're going to test two basic cases. Firstly, if we're given an empty list and we reverse it, we should get back an empty list. So what this block of code does here is basically we create an empty list called empty list, and then we reverse it, and then we should check that once we reverse it, the list is still empty. The other case, which is the more common one, is if we actually create a list with elements in it. And the list that we're going to test is a list called 1 to 5, and this simply contains the elements from 1 to 5 in that order. So when we reverse it, we should get 5, 4, 3, 2, 1. We should still have the same number of elements. We should still have 5 elements in the list. And hopefully, if our reverse function works properly and passed both these tests, we should get a message saying, reverse this function test passed. Okay, so that's what we're going to be doing in this video. So, as always, with any kind of linked list question, before we start, we should always draw a diagram and draw our general approach. To reverse the list, what you need to do is reverse the direction of the arrows. So we're going to start with this left arrow here. What we need to do is flip this arrow. Now the first arrow is a bit of a tricky one because when we flip it, we need the first arrow to point to null. Because by definition the first arrow here is now the end in our reversed list. And then we're going to flip all the other arrows too. So this arrow, we're going to flip that, like so. This arrow, we're going to flip it, like this. And then the last arrow, which was initially pointing to null, we're going to flip it. Let's see. Like this. And hopefully, after we've done that, we should have 4 arrows pointing, when they were initially pointing to the right, now they're pointing to the left. But as you can see, the blue arrow is pointing to our old first. We need to change this blue arrow at the very end to point to the end. So, in other words, we want to make this blue arrow point all the way over here. So those are the two basic things we need to do when we reverse a list. The first thing is we need to reverse all the arrows, and then secondly, we need to change the head. So let's actually just do that in pseudocode. Let's go to list.c. So the first thing we need to do is reverse the arrows, and secondly we need to change the head. Okay, so now we're going to look at how we would go about reversing the arrows in a little bit more detail. So say we've already reversed the first 2 arrows, we want to fill this gap here. How would we do that? Well, essentially what we're going to do is we need to take this arrow and make a point here. But when we do that, we have to be careful. As with anything in linked lists, we have to ensure that we don't get any data leakages. So what we do is we create temporary pointers. Firstly, we need a temporary pointer that points to the current node we're at, and we'll just call that current. So we know which arrow we're going to adjust. Current, arrow next. This is the arrow that we want to adjust. Now, when we're adjusting this arrow, we need to set it to a particular target. We want to set it to point to this node. But we don't know where this node is, so we're going to have to store it somehow. And we're going to call it stored in a pointer called before, like so. Okay, So now that we have current and before, we're ready to flip the arrow. Well, let's have a look. So if we flip the arrow, and we make the new arrow like this, then we want to move on to the next arrow. But there's nothing pointing to this node now. So before we actually cancel that arrow, we need to create another pointer, a storage pointer, and we're going to call that pointer after, like this. Okay, so now that we have an before, a current, and an after, we have now held on to all three nodes that we need to hold on to. We need to hold on to after, of course, so that once we've deleted this grey arrow and created this purple arrow, we can still hold on to the rest of the list, basically. And after we've done that, we need to move on to the next node. And to do that, we need to shift these storage pointers forward, like that. So that's the basic case. This will only work if we're dealing with a node in the middle. Where it gets tricky is when we start dealing with cases at either the start or the end, but we'll get to that later. So we'll do the easy part first, which is doing it in the middle. So, as I said before, we'll need 3 different storage kind of pointers. So create a node pointer before, node pointer for current, and a node pointer for after. I'm not going to initialize them just yet because, as I said, it gets a little bit tricky when we think about the start. So we'll start with the middle first. So in the middle, we're going to have to do some sort of while loop which loops through each of the individual nodes. We don't quite know what the condition is yet, so we'll leave it blank. Some random condition. But the steps are basically the same. So the first thing we did, let's just shift these arrows back so that it makes a little bit more sense. So the first thing we did was we took this grey arrow and made it point in the direction of the purple arrow instead. So this grey arrow is described by current arrow next. So we want current arrow next to point to the same thing that before is pointing to. Or in code, we say current arrow next equals before. And after that, what we want to do is we want to shift these pointers along. So in order to shift these pointers along, we see that before will go to where current is now. So we say before equals current. I should probably comment some of this stuff. So this part is actually flipping the arrow. And the next part is what we call shifting the storage pointers. Okay, so we've shifted forward the before storage pointer. Okay, so now we've done this. Now we want to shift forward the current one. Why is it not transparent? So we've shifted forward the before one. Now you want to shift forward current to point to where after is pointing to. So we say current equals after. And then finally, after, we need to shift after forward, and we do that by saying after equals after arrow next. Let me just fix some of these up. So we say, after equals after arrow next. Okay, so that's our basic while loop. So that's kind of like the middle of reversing a list. And as I said before, the really tricky part of this exercise is determining what happens at the start and at the end. Let's tackle the end first, because the end is essentially what determines the condition in our while loop. So, whilst we're shifting these storage pointers along and reversing those arrows, we do this one, then we do this one, and then we do this one. Now, and this is actually the end of our while loop. Why? Because if we have a look at this line, after equals after arrow next, if we shift it forward again, well, if we do it here, we see that after is pointing to null, and therefore after arrow next doesn't exist. So we need to stop it here. So our stopping condition, if you have a look, we see that after is pointing to null. So that is the condition in our while loop. While after does not equal to null. So keep running it until after equals null, and then we get to this stage. Okay, this stage is quite interesting. So this arrow, it will look like this. So when we get here, what do we have to do? Actually, no, that arrow wouldn't have been created yet. What we have to do is, once again, we have to take this grey arrow, we have to cancel it out, and then make it point here instead. So once again, it's the same kind of logic. So the grey arrow is described by current arrow next. We want to set that to where before is pointing to. So in code, we simply say current arrow next equals before. And here's the tricky part. Remember how I said at the end we have to change the head? So let's go ahead and do that. What we have to do is get rid of this blue arrow. Actually, just get rid of this blue arrow, and then make it point to current. Alright, so the blue arrow was described by L arrow head. So what we're saying is basically here, L arrow head equals current. Alright, so that basically deals with the end. Well, if you think carefully, it almost does. It doesn't quite deal with the end in that if you have an empty list, after won't be pointing towards anything. So we have to deal with that case separately. But before we think about that, let's just go to the start. So start is quite tricky because at the start our pointers will look something like this. That blue arrow won't be pointing there, it'll be pointing here. So when we start off, the blue arrow, which is described by L arrow head, is where current is pointing to. So in other words, when we initialize current, we need to initialize it to L arrow head. Okay. Now, as you see at the very start, before is pointing to null. So that's what we have to do. So no point before equals null. Okay. What about this after one? Let's have a look. So after, if you pretend this grey arrow is pointing to the right instead, it's simply current arrow next. That is if the list is not empty. However, if the list is empty, after arrow next doesn't exist. So we'll have to do some sort of an if statement here to get around this. So we'll say if the list is empty, that means that current equals null. So that means if the list is empty, so if current equals null, then we don't need that after pointer, we'll just null it. Otherwise, we'll set after to be the thing after current. In other words, after is current arrow next. Alright, so now we've dealt with the start, we've dealt with the middle, and we've dealt with the end. So hopefully, if we cross our fingers, this should work. So let's go GCC minus wall minus where minus big O minus little o, and our thing is called, let's call it list tester. and we have list.c and testlist.c. Right. So it didn't compile, so what happened? Suggest the parentheses around assignment. Ah, okay, I forgot the double equals, silly me. Where did I do that? Alright, so let's try again. Okay, so compiled, and let's run list tester. Alright, so we got another error. Let's see what happened. It didn't reverse the empty list. Okay, let's have a think about why this might have happened. So we're in the empty list case. In the empty list case, after is set to null. Okay. Before current and after should all be set to null. So in other words, this while loop won't run. Let's see. Oh, look, have a look at this line. Current arrow next. Actually, no, that's yes. Current arrow next is before. However, because current is pointing to null, current arrow next doesn't actually exist. So we have to do something different here. In this case, if current is pointing to null, we actually don't have to run this line. So we just do a simple if statement. If current equals null, we don't do anything. Do nothing. Otherwise, oh, my bad. Otherwise, do that. So let's try that now. Scroll down a little bit. Alright, and you can see down here, we created and successfully reversed our empty list. And we created the list 1, 2, 3, 4, 5, we reversed it, 5, 4, 3, 2, 1, it passed our certs, and we are awesome. And that is basically how you reverse a list. I'll upload this code in a blog post, and if there are any other functions that you want me to do, I'll see if I can post up some more videos in the last minute. And for those of you who are watching, I wish you the best of luck for your prac exams, and may the stars be with you. Cheers.